The law of cosines is found from taking a side that you're looking for and squaring it. And that is going to equal to the sum of the squares of the other two sides minus 2 times those other two sides times the angle of the cosine of the angle opposite the side you're looking for. So to solve using this particular formula right here, I would need to know the values of B and C, and I would need to know the value of angle A. If you remember when we were doing the law of sines, you had to have the angle that was opposite one of the sides you have. In the law of cosines, you can solve the problem knowing two sides and an angle, but now the angle is not opposite one of the sides you have. So it finishes out. If I have any two sides in a triangle and an angle, I can either use the law of sines or the law of cosines to find the solution. So guarantee me two sides and an angle, and I guarantee I can give you everything else in that triangle. So we're going to practice today using the law of cosines. So just remember, it's the side you're looking for squared is equal to the sum of the squares of the other two sides minus this thing, 2BC cosine A, where A is the angle opposite this side, and BC are the sides that aren't this side. And you should know what 2 is, and you should know what cosine is. Everybody okay with that? This is a formula that you're going to have to memorize. So my advice to you, since you need to know it by the test, which I think I'm pushing the test back until Thursday of next week instead of Wednesday of next week. I think we'll do a whole nother day, Monday, practicing, and I'm going to mix up sine and cosine problems. Law of sines and law of cosine problems. But since you have to know this formula, you don't wait until Wednesday night to try to memorize the formula. You start trying to memorize it tonight. Make you a note card when you get home. Look through the note cards tonight. Look through them Saturday night. Look through them Sunday night. By the time we get to class on Monday, you'll probably already have the formula memorized. If not, you've still got 3 more days before the test to get that formula memorized. But you need to start now. You don't wait till the last minute to do that. Everybody okay? All right, let's look at an application. So here's a problem where we've got a triangle that we could not use the law of sines on. There is no way to solve this to use the law of sines because sine 44, I don't know what B is, and I don't have any way of finding these other two angles. So the law of sines, what we did yesterday, won't work in this problem. However, we're doing something completely different today where it will work. We are looking for which side? Side B. So what I'm going to, yes. Okay, so what I'm going to do is I'm going to write the formula in terms of side B. So that means the first thing that I write down is B squared equals. And it's going to equal the square of the other two sides. So that would be A squared plus C squared minus 2 times the other two sides times the cosine of the angle that would be opposite side B, which would be which angle? Angle B. So there's my setup. So now I got to figure out where A and C is. Well, A is the length that's opposite angle A, and C is the length that's opposite angle C. So we okay with that? So basically in this problem, A is 22, C is 10, and angle B is 44. And that lets me fill in that variable, that variable, that variable, that variable, and that variable. All the variables on the right side I can fill in. Yes, sir. Okay, here's angle A. The side opposite angle A will be little a. And it's marked 22. Does that make sense? All right, so I'm just going to fill this in. B squared is equal to, what do I put? 22 squared. What do I put? 10 squared minus 2. What do I put? 22. What do I put? 10 cosine 44 degrees. Does everybody understand that? And at this stage of a game, it's just a plug and chug in your calculator. Now I'm going to break it down into some smaller parts first. I'm going to go ahead and do 22 squared plus 10 squared. Okay, so 22 squared in my calculator is 484. And then when I add 10 squared to that, that's just adding 100 to it. So 22 squared plus 10 squared is 584. So these two numbers right here, I don't like red, the highlight. Let's do yellow. These two numbers right here simplify down into this number. Everybody with me? Minus. And I'm going to go ahead and multiply 2, 22, and 10. 2 times 22 times 10. That simplifies to 440. So this information right here simplifies to that. And now you have something that's a little bit easier to punch into your calculator. So if you want to enter all of this stuff into your calculator, that's fine. I'm going to break it down. However, that gives me b squared. What am I wanting to find? B. So how do I undo squaring? So I will take the square root of both sides. And so b will equal the square root, and this is what I'm really going to put in my calculator. 584 minus 440 cosine 44. So let me show you how I would punch all of that into my calculator. Can you see the calculator pretty good? All right. So into my calculator, I would put in 584. Oh, I'm sorry. I would put in the square root. And in my calculator, the square root opens up a parenthesis. Some of you, it might just extend the line. 584 minus 440 cosine, what was the angle, 44 degrees? 44. Close the parentheses for the 44 degrees, and then close the parentheses for the square root. And then I hit enter, and I get 16.35. I think the directions told me to round off to the nearest tenth, so 16.35 would round off to 16.4. So I go back here, and the value of b is equal to 16.4. Is everybody okay with that? Any questions about what I did? Okay. Yes, ma'am.
Could you simplify would it have made a difference if you simplified 540 minus 440 to be?
Yes, it makes a huge difference. Why?
I was just wondering.
No, I mean, why do you think? I'm telling you it makes a huge difference, and then I'm asking you, do you know why?
Because if you're taking the square root of 584 and taking the square root of 440 is different from taking the square root.
Right, and even more importantly than that, what operation do you think is going on between 440 cosine 44? And what operation is going on between these two numbers? Which comes first? Right, you're supposed to do multiplication before you do the subtraction. So you absolutely have to multiply this stuff before you start subtracting anything. So you're not subtracting 440 from 584. You're subtracting the product of 440 and cosine 44 from 584. Right. So see, it messes up your whole answer. If you don't follow orders of operations, it messes up your whole answer. Just like if I had 5 minus 2 times 10, it's not 30. It's some negative number, negative 15. It's a huge difference. Nate, are you with me?
I see how to do it. I just don't know how to do it in the calculator.
Okay. We'll work with your weird calculator one-on-one. We have time at the end. All right, so here's what I want you to do. I want you to try to do this problem. So let me make it a little bit bigger so that it's easier to see. Let's do it like this. Let me just make this bigger.
part's gonna be knowing which formula we use.
Yeah, and that's why I'm thinking about Monday doing some problems where you have to pick between the two methods, law of sine, law of cosine. All right, so go ahead and see what you could do with this problem right here. All right, the answer is 61.8. Is what we're getting in class. Let's see if that's correct. I kind of feel like that's a pretty strong answer. So let's see where we line up on this. So the first thing about this problem, the key is going to be the setup. So I'm going to use little l, and I'm going to make it cursive because l's kind of look like ones. So I'm going to use little l opposite angle l. Since that's the side I'm looking for, it's little l squared is equal to. The other sides are little n and little m. So it would be m squared plus n squared minus 2m in cosine. And remember, the cosine is going to be the angle opposite the side I'm looking for. So in this case, it's going to be a cosine of angle L. So that's the formula I would have used to solve this. So this is like a squared because this is the side I was looking for. This is like b squared, c squared, bc. And then this is like angle A. This angle right here should always match in letter form this side that you're looking for. That'll help you keep the formula organized. Any questions about how I set up the formula? Now let's start plugging. You got a question? Yeah.
Does it matter if we like switch the letters in that? Because I put L squared plus N squared, or L squared equals N squared plus N squared.
Okay, so my question to you is addition symmetric? Is 3 plus 4 the same thing as 4 plus 3? Then what you did is okay. Doesn't matter what order you add in, it's when you start subtracting the order starts to matter. So L squared will equal, M was 29 squared, but you could have put 48 first. N is 48, but you could have put 29 second. Minus 2 times 29 times 48. And then the angle that you're taking the cosine of is the 104 degree angle. So that's the plugging in all the numbers. Okay, if you want to simplify it up a little bit before you put it in the calculator, you can do 29 squared plus 48 squared. And that's 3145. And then 2 times 29 times 48 gives you 2784. And then L will equal the square root of all that. So don't forget to take the square root. That's important. Bless you. All right, so this is what I'm going to punch into my calculator. And I get 61.79, which I'm going to round up to 61.8. And I think that's what we all got, isn't it? All right. That's all there is to it. That's all there is to using the law of cosine when you've got an angle, but you don't have the side opposite that angle, and you have two sides. I kind of call this a side angle side situation. So remember in the law of sines, we looked at having two sides in an angle. That means the angle wasn't included between the two sides. And we also looked at two sides, an angle and two sides. So, or two angles and a side not included. And then in the law of cosines, our angle now becomes included. It's kind of a side angle side situation. So, Maddie, you were talking to me about when do you know what to use for what formula?
I just worked it with all the formulas and it worked, and I don't think that.
Okay. Now, I mean, you're talking about knowing whether to use law of sines or law of cosines. So one of the first things you can think of is if you have an angle side, that's law of sines. If you have an side angle, that's the law of sines. If you have side, angle, side, where the angle is included between the two sides, that's law of cosines.
So like if 29 would have been where the little L was, we would have used.
You would use law of sines. All right, and then the other situation we can have is where we have all the sides, and now we're looking for the angles. So now we're going to use the other version of the formula for cosine, the law of cosines on the board. I'm going to show you how I developed that formula. And I mean, I didn't develop that formula. This is how the formula is found. So normally, it's a squared is equal to b squared plus c squared minus 2 bc cosine angle A. Well, let's say my variable that I'm looking for is the angle and not one of the sides. You know, previously, I could move the b squared over here, and then I would just shift the a squared over here and change the b to an a. Or if I was looking for c, I could move the c squared over here, move the a over here, and shift the c to a. But what if I'm looking for the angle, and I've got everything else? Yeah, so I need to solve for a. So how do you solve for a? I think the first thing I'm going to do is I'm going to use the symmetric property to rewrite this. Is everybody okay with that?
Yeah.
All right. And then I'm going to start solving for angle A. So what's the first thing that has to go away in angle A?
The B, C, and
The B and the C are the things that I can undo using subtraction. So whatever you subtract from one side, you subtract from the other side. So that's going to leave, those will cancel out. That'll leave me with negative 2bc cosine A is equal to a squared minus b squared minus c squared.
So really, you only need to memorize the first thing.
Well, I mean, you don't want to go through deriving this the whole time. I'd memorize the two formulas up there.
Yeah.
I'm just showing you how it's found. So now what's the next thing I need to do?
Divide.
I need to divide and get rid of negative 2bc on both sides. Yeah, you wouldn't want to do this every time. I'm just showing you where the other one comes from, that it's still the law of sines. It still is the same theory, it's just a different version of the formula. And then how do you undo cosine?
Inverse.
Right. So to undo that, you would do cosine inverse of both sides. And over here, cosine inverse would cancel with cosine. And now you're just left with, the measure of angle A is equal to cosine inverse a squared minus b squared minus c squared all over minus 2bc. So you've got this formula on the board up there. That's where it came from. So how do you know when to use this formula? When it's asking you to find the measure of an angle. If you have a side situation, we're going to use this version of the law of cosines formula. All right, so I've written it up on the board. You've got it up on the board to keep track of it. Now let's work this problem. What's the first thing you would do in this situation? Remember, a lot of people are visual learners. Let's draw a triangle. Triangle's not going to be drawn to scale, but I'll go ahead and slap some stuff up there and then label it T, U, and V. What's the length of TU? 4.4. By the way, what little letter do you think this would equal?
V.
It equal little letter. Why V? Because it's opposite angle V. What is UV equal to? 7.1. What little letter does that equal? So little t is equal to 7.1, and then obviously this is little u, and it's going to equal to? TV is 6.7. All right. So my formula is I'm looking for angle V. So I'll call this X. So angle V if I'm using the formula on the board, is going to equal to, what's the side I put first? So if this were A, where would little a be? If this were angle A, where would little a be? Be over here. So 4.4, the side that's opposite the angle you're looking for, is what goes first. And then we're going to subtract off the other two. Does it matter what order we put them in? No. So I'm going to do minus 7.1 squared minus 6.7 squared. And that's all over negative 2 times the two numbers that were subtracted in the top. 7.1, 6.7. And then I forgot to leave room, but I need to have room to my cosine inverse. So really this is the cosine inverse of all of this stuff. And you can just put all of that in your calculator. So the measurement of angle V or X or whatever you want to call it is the cosine of all of this stuff. Cosine inverse of all of that stuff. So I think what I'm going to do is I'm going to demo to you how I put it in my calculator. Okay? So let's take a look at my calculator. Here's the equation right there, or the expression right there that I'm putting into my calculator. And so, can we see the calculator okay? All right. So I'm going to do inverse cosine. I would get into the habit of any time I have a numerator and a denominator grouping those two things. That is the most common error I see people make on calculator punching in. They forget to group the numerator and the denominator. And most importantly, what happens is, if you forget to group the denominator in this one, it will divide by the negative 2, but then it will multiply by the 7.1 and the 6.7. And it won't consider those as division parts, it'll consider them as multiplication parts. So just get in the habit of grouping numerators and denominators. So 4.4 squared minus 7.1 squared minus 6.7 squared. Close the numerator group, do my division key, open the denominator group. Negative 2 times 7.1 times 6.7, oops, not 67, 6.7. Then close the denominator group, and then close your cosine inverse. And when you hit enter, it should punch it out all the way to the correct angle. Yeah. So there's just a lot of stuff to put in. So sometimes you might want to key this stuff in a couple of times on a test to make sure that you're putting down the right answer. So I got 37.0. If I were to round this off to the nearest degree, to the nearest tenth of a degree. So I need 37.0 is the nearest tenth of a degree. Okay, yes, sir. You may. Okay, if you got a domain error, that means you might have tried to divide by 0 by accident, or there's not enough parentheses or something.
Mr. Ricker, what did you say you need to do to check your calculator?
The first thing you need to do is take the tangent of a 45 degree. And you should get 1 as an answer. So let me go through the calculator punching again.
If you go to put in the fractions, it gets the right answer. Because I tried to do the division thing and it gave me the wrong answer, but I put it in the fraction form.
So you want me to just put it in the fraction?
Yeah.
So if you put it in the fraction form, then you don't have to worry about grouping.
Yeah.
So, like I was saying on a test, when you get done with your test, it might be a good idea to go back and rekey in every complicated calculator conversion that you did to make sure that you just didn't accidentally mispunch a key. You can also use a little bit of logic when you're examining your answer. For example, in this particular problem right here, I was finding the angle measure of the smallest side. So I would expect a fairly low degree angle. I would expect if I found all the angles of this triangle, this would be the smallest. 37 fits into that. If I had gotten 93, but this was the smallest side, there's no way that could have happened because 93 has to be the biggest angle, but it can't be because it's supposed to be opposite the smallest side. All right. So now I want you to practice one. So we've got about 6 minutes of class time left. I'm going to let you practice it for about 4.5 minutes, and then I'm going to work it real quick. All right, so this is the exact same triangle with the exact same numbers. However, we're finding a different angle. So the angle that we're going to find on this one is angle T. So how does that change what our numbers look like? Well, now it's the measure of angle T is equal to the side opposite T is going to be your first number over here. So cosine inverse 7.1 squared is your first top number. And then you're subtracting off the other two numbers squared, 4.4 squared, and 6.7 squared. Then in the bottom, it's -2 times the two numbers that came after the subtraction, 4.4 and 6.7. Remember, don't square them in the bottom. Only square them in the top. So you could just put that directly into your calculator. I'm going to show you how I put it into my calculator. So in this version, this was 4.4, and this was 7.1, and this is 4.4. So it's cosine inverse, open parentheses for my numerator, 7.1 squared minus 4.4 squared minus 6.7 squared, close parentheses for my numerator, division key, open parentheses for my denominator, -2 times 4.4 times 6.7. And I got 76.4 rounded to the nearest degree. 76.4 seems kind of logical because that could potentially be the biggest angle in the triangle, and it's opposite the biggest side. All right, your homework tonight is this, and we will go over this stuff on Monday.